Assalamu alaikum. In this lab, we will learn about the basics of quarters, and we'll also see how to create a project and run some of its simulations. So to do that, let's go to the new project wizard, and after the new project wizard opens, click next. The name of the project should be selected. Let's see if we are making the project as lab 10, and next okay, empty project. Next, and we don't have any board connected to our PC right now, so that doesn't matter, and we have to select the language or the simulation as the model sim Altera and Verilog HDL. Select next and then click finish. And after the project opens, you have a window in front of you in which you can then write your code and then see it in the RTL viewer. To write the code, click this new button, and after this window opens, select Verilog HDL file, and I have the code already copied, so I'll just paste it right here. And you have to make sure that the name of your highest level entity right here matches the name of your module. So MuxLab 10 matches the name right here, and this is the code of the multiplexer. And I will explain to you how this code is actually working. This is the name of the module, as I've said earlier, and this is these are the name of the pins that are going to be used in this module. One of this pin out is declared as an output, and all the other pins are declared as an input. Now we know what a multiplexer does. It takes inputs, and on the basis of its selection lines decides which of the input is to be shown at the output. So now we are assigning this output as the NOT of S1 and S2. That means the selection lines when there will be 0 and 0, and the input then the input 1 will be at the output. If the selection lines selection line 1 is 0 and selection line 2 is 1, then input 2 will be shown at the output. Same goes, say another case is that when S1 is 1 and S2 is 0, then the output will be an IN3, and if both the S1 and S2 are 1, the output at will be IN4. So this code is actually complete right now. This code will enable it to work as a multiplexer. We have to click the start compilation, click yes. The name of your multiplexer, let's name it as MuxLab 10, and once that's done, click enter, and now the code is actually compiling. And once that code is compiled, all we have to do is show the code in the RTL viewer, and after that we will see what its waveform looks like. Now the code is actually compiled, and let's see what we have got in the RTL viewer. And once the RTL viewer opens, this is the diagram we've got. Now if you look closely, this is what a multiplexer actually looks like. This is the first output bit, this is the second, third and fourth bit, and each bit is specified by what input it takes. So this was the view in the RTL viewer, and now let's see what waveform do we get, and if it actually is verifiable from these pins. So we have to insert node finders, we have to list them all, and then this and then OK. Now we have all the inputs and all the outputs. So let's start like this. Let's select the time period of the S1 as 800, time period of S2 as 400, time period of IN1 as 200, time period of IN2 as 100, time period of IN4 as 50. And time period of IN4 as 25. So these are our inputs and these are the selection lines, and if we run it we will get a waveform which I will explain to you after I get it. For some reason the simulator is not actually working. Let's try that again. This Altera is not actually working, but this was the basic code of basic lab on how to upload the code onto the Quartus and how it actually works.